Okay, so now we're going to have a look at some inverse functions. So when one function undoes the work of or does the opposite job of another function, they are said to be inverse functions. So for example, here we have the function 2x minus 7. So so what that really means is we multiply the input by 2 and subtract 7. The inverse, so that's our symbol for inverse, so looks the same with the little minus 1. In this case, we add 7 to the input and we divide by 2. So you can see they're opposite operations to each other. Where we were multiplying by 2, we're now dividing by 2. Where we subtract 7, we now add 7. So they're total opposites of each other. A function f has an inverse if and only it is bijective. So it has to be bijective for this to be possible. And a function cannot have more than one inverse. So a function only has one inverse. The third point is if you do a composite function, so if you, in the first case here, if you put a value, so if you put the inverse into the original function and you put the function into the inverse, you should be left with just x. I know that doesn't make too much sense at the moment, but when we do an example, you will see what I mean. So let's start by just learning how to find the inverse of a function. So a few easy steps here to follow. First of all, you call it y. You start off by calling it y, which makes sense because another way of saying function is y equals. You then get x on its own, and then you replace the y's with x's. So let's look at an example because it's not really until you see an example that it makes sense. So here we have our function 3x minus 3. So I change my f of x to y, which is no big deal because we know that another way of saying f of x is y. What I do then is, as if I was solving, I get x on its own. So I move over to minus 3 plus 3. And I have 3x here. So all I'm doing is, as if I was solving, I get x on its own. So I end up with y plus 3 over 3. So that's my answer, basically. That's my inverse. But we're going to write it a little bit nicer. So what we're going to do is we're going to write with the symbol for inverse. So that's the first thing. Now, remember, we're going to replace all the y's with x's. So we end up with x plus 3 over 3. Now I'm done. So let's compare. The original function was multiply the input by 3 and take 3. The new function is add 3 and divide by 3. So you can see that indeed it is the inverse. So that is how we do the inverse. And just to mention the bijective thing, over here we can see the domain is OR, so all values that you know of, and the range is, or the codomain is also OR. Now, if you think about this function, it's a straight line, an upward straight line. So my domain, so if I read any of my values, it is possible, and of course it goes into the negatives as well, all y values are possible. So because the range equals the codomain, they are literally equals to each other because all y's are possible, then it's bijective. Well, it's surjective technically. It is also injective. And then because it's both injective and surjective, it's bijective. Or another way, of course, is our horizontal line test. If I do a horizontal line anywhere along the straight line, we can see that it will only touch it just the once. And if it touches it just the once, it's bijective. Now, you haven't been asked to say that, but or to show that, but I was just explaining that in order for this to have an inverse in the first place, it has to be bijective, which it is. Okay, let's practice that again. So let's do this. Let's get the inverse of this guy. So we start off, and I'm just going to replace g of x with y, just to make it a bit more, I suppose, something we're used to seeing. Now, my second step then is I want to get x on its own. So as if I was solving, basically. So I'm going to pop this guy over 1. I'm going to cross multiply. So I end up with y, sorry, y bracket 3 minus x, 1 times 1. So I end up with 3y minus xy equals 1. Now remember, my goal is to get x on its own. So I'm going to bring over the 1 and put the xy back over. To get x on its own, then I'm going to move the y. So this is what I end up with. So I'm basically done, but I just need to put it back into a format that is correct. So I do my symbol for my inverse of a function. Okay, same as normal function with little minus 1. Then I replace all my y's with x's. Now, let's see if this does indeed make sense. Well, up here, the 3 minus x was doing the dividing. So first of all, we have complete reversal. We have 3x, so we're multiplying by 3, and we're taking 1, and then we're dividing by x. So it's a complete alternative way, backwards way of doing everything. It undoes the work of the other. So why is it that, why is it that it does even have the inverse? So when we're doing the domain here, so let's say up here it says or less 3. Now let's just explain this for a second. My domain is basically all numbers, because or is real numbers, all numbers except, that line means less 3. It's pronounced less, but it means except 3. Now, why is that? Well, because look at the question. If x was 3, you'd end up with 3 minus 3, which is 0, and you can't divide by 0. So that's one of the stipulations of this thing. And then in your codomain, again, your codomain is all numbers except 0. Okay. So for your codomain, you can have any number basically except 0. So just to explain, that's what that line means. It's pronounced less. So you do or less 0. But in simple English, it means all numbers in the real set except 0. Okay, just to explain that. Okay, we'll do another one here. So we change this to y. So the first thing we do is we change the symbol to y. We then gonna get x on its own as if we were solving. So I end up with y, 8 times y is equal to 12 minus 3x times 1, which is 12 minus 3x. I get x on its own, so I'm going to bring the 3x over, bring the 8y back. And then to get x on its own, we write all of this over 3. So I then just write it a little bit nicer. So I use my symbol for inverse. So the inverse function of h is 3 minus 8x, 12 minus 8x, sorry, over 3. Okay, and here my domain is or. So all numbers are possible, and my codomain is or. So in this case, all numbers are possible. Okay, we could have a look at the graph. We could talk about the fact that a horizontal line test means that it only hits the graph once, which means it's bijective. But anyway, we don't need to go into that. All we're doing here is just writing the inverse function. Okay, I'll continue in the next video.